today is the magic day. We are going to do our first proofs. I don't know what you've heard about proofs, but we're going to be doing proofs for a lot of first semester here. And so section 3.3, we are going to actually do our very first actual two-column proof. What I'd like to do, though, is I'd like to start out by giving an analogy. And I start with the analogy as this. I usually ask my students in class, if I were starting at the Northfield campus, and I'm at New Trier High School, Northfield campus, and I wanted to get to O'Hare Airport, what streets would I take if I were driving? So the Northfield campus is on Hap Road, and so I would probably drive north on Hap Road, and then I would hit Willow Road, and I would go west on Willow Road, and then I would hit 294, which is the Tri-State Tollway, go south on the Tri-State Tollway, and then I think I get off at whatever the O'Hare exit is. Off of 294, and then take that to either the arrivals or departure section or the parking areas of the O'Hare Airport. Now, we're going to provide the beginning, we're going to provide the end point. You have to provide all this stuff in between. Okay, and it has to be in a particular order. You can't just go from the Northfield campus and hop on to 294, for example. You're missing a bunch of steps. You can replace a couple of steps. So, for example, I could have gone from the Northfield campus, Hap Road. I could have taken to Winnetka Road and gone west on Winnetka, and then taken a right on Waukegan, and gone north on Waukegan, and then I would have ended up hitting Willow Road and going west on Willow Road. So I would have added a few steps as far as the number of streets I go, but I would end up still following this path of going from Hap Road to Willow Road, then 294, then to the O'Hare exit. Okay, so that's basically what we're doing here. We are kind of going to have a starting point and an end point, and we're kind of filling in the blanks. We're kind of creating, if you think back to the first section of chapter 3, we're creating that chain of reasoning. And if you remember, the chain of reasoning was exemplified with the DirecTV commercial. Okay, right? And so that's what we're basically doing when we're setting up a proof. Let's go ahead and try a proof together. We'll actually try a few proofs together, and hopefully it'll start making some sense to you. So, we're given a statement. That's our Northfield campus. That's our starting point, and we're asked to prove that these triangles are congruent. That is our end point, or the O'Hare Airport. When you do these proofs, what I would recommend you do is you take the given information, and here's the diagram over here to the right, and mark your diagram. So it says that LV is the perpendicular bisector of IE. So perpendicular bisector, we know from the earlier chapters, means that it bisects this, so it's the midpoint. So that means that this is congruent to this, and I know that it's perpendicular to it because it says it's perpendicular. I also might want to mark the fact that I know that LV is congruent to itself, and I like using that kind of squiggle thing when we're talking about something being congruent to itself. This property, when you're saying that something is congruent to itself, is called the reflexive property. And so we'll talk about that, where to put that when we're setting up our proof. Now that I see the diagram, I can hopefully spot the fact that these two triangles are congruent by SAS, and that's from the last section. And that's how we're going to prove the triangle's congruent, by side, angle, side. So let's go ahead and write the proof. The first thing that I'm going to write is, in this column, my various statements. And I'm going to number my statements, and I'm going to number my reasons. Please make sure you number those. So the first starting point is going to be that LV is perpendicular bisector of IE. And the reason why is because it's given. And I'm just going to let you write a big G for given. Step 2, well, if I know that it's a perpendicular bisector, then what information do I know? Well, I know that IV is congruent to IE. I know those two segments are congruent, and the reason why is because if you have a bisector, then you end up with two congruent segments. Okay, and then in step 3, I also know that, what do we know? We know these things, right? I know that angle LVI and angle LVE are right angles. That's because if I have perpendicular lines, I'm going to go ahead and use the abbreviation symbol here for if and then. If I have perpendicular lines, then I have right angles. If I have right angles, well, then I know that those right angles are congruent to each other. LVI is congruent to LVE. And the reason why is if I have right angles, then they're congruent. So right angles are congruent. Step 5, I want to write down this thing, this idea that LV is congruent to itself. And that's going to be by the reflexive property. I will let you write reflex. I'm kind of big on abbreviations here because our proofs are going to end up being very long. And then now I know that, well, I have a set of sides congruent, a set of angles congruent, and a set of sides congruent. I know that triangle LIV is congruent to triangle LEV. I'm at my finish line, my destination. And the reason is going to be by SAS. And the steps that comes from, these are called reference numbers. And I do want you to write down reference numbers when you're proving the triangle's congruent. So steps 2, 4, and 5 is where that comes from. Now it just so happened that when I wrote this proof out, it just happened that I ended up with this in this order, the S, the A, and the S. You don't have to have it in that particular order necessarily. I could have had the S and then another S and then an A within the proof itself. Okay, once I finish that, I am done. And you've just written your first proof. Okay. Now notice, all the reasons here, they're all general reasons. General. There's nothing specifically pointing out something from the diagram in my reasons. All the statements have to do with stuff that's going on in my diagram. Okay, and I will be giving you a reason sheet at some point, and you can, if you're having trouble coming up with the reasons, you can use that cheat sheet, the reason cheat sheet, so that you can remember these reasons. You're not going to get to use a cheat sheet, unfortunately, on tests and quizzes, but you can use it as you're trying to learn these different reasons. Okay, let's try the next proof. So proof number 2 here. Given that angle S is congruent to angle G, I'm just going to mark the diagram here, like I mentioned, and I is the midpoint of SG, so that means that this is congruent to this. And let's see. One thing that I know I'm supposed to introduce here is that this is congruent to this. These are called vertical angles. And what's true about vertical angles is if you have vertical angles, they're going to be congruent to each other. So anytime I have two lines or two line segments that are intersecting with each other, I'm going to create vertical angles. So I know that, for example, these angles are congruent to each other, and I know these angles are congruent to each other. Sometimes some books refer to these as opposite angles, but we're going to use the term vertical angles. Now, once I identify that, I can see, hopefully, that this triangle is congruent to this triangle, and the reason is just going to be by angle, side, angle, and it's going to be triangle SIT congruent to, make sure you get the letters right, GIN. Okay. All right, so let's go ahead and write this proof. So I know that angle S is congruent to angle G. I know that I is the midpoint of SG, and the reason why is that it's given. I can go ahead and write those in separate steps if I want. I can write them as in one step as long as the reason for that one step is the same. Step 2, I know that SI is congruent to IG. And I know the reason why is because if I have a midpoint, then it splits segment into congruent segments, or something like that. Step 3, I can do the vertical angles. So angle SIT is congruent to angle GIN, and we know that's true because of this. Vertical angles are congruent, or if vertical angles, then they are congruent. You can write it as that. And then the last step is just going to be the triangles are congruent. So triangle SIT is congruent to triangle GIN because of angle, side, angle, and don't forget the reference numbers from steps. Looks like I got an angle here, I got a side here, another angle here, so it's going to be steps 1, 2, and 3. Okay, I think there's one more property that I need to introduce here, and that is something called the transitive property. Before we move on to the backside and talk about, maybe introduce one or two more proofs, transitive property works like this. If angle A is congruent to angle B, and angle B is congruent to angle C, if that's true, then angle A must be congruent to angle C. That is by what's called transitive property. Okay, so hopefully that's something that will pop up when we're doing proofs, and that you can use as a reason here. You can use transitive property. All right, let's move on to the backside. Okay, moving on to the back side here. Let's try a couple more proofs. We'll start with the first one here. Proof number 3. I know that IL bisects angle GIR. So angle GIR is right over here. And I know that this angle is bisected or chopped in half by segment IL, which means that this angle is congruent to this angle. And so that's this one here. And I know that IL bisects GLR, so it chops this angle in half. So I know that this angle is congruent to this angle. And let's see, what else we got here? We're trying to prove the triangles are congruent to each other. Looks like GIL is congruent to triangle RIL. I'm trying to get the letters right. And I have a side and a side. No, I mean I have an angle and an angle. And it looks like I can do that this side is congruent to itself, again, by reflexive property. Which means that the triangles are congruent by angle, side, angle. So let's go ahead and write out the proof now. So we know our starting point is just going to be these two guys here on a test or a quiz. Please do not do what I just did there. For the sake of time, I just did that. But that's going to be given. Again, I can group those together because they have the same reason. And as the proofs get more complicated, please don't just throw down all the givens into the first step. Use them when you need them, and you'll see when we get to more complicated ones, you'll see what I mean by that. Because they're bisected, I know that angle GLI is congruent to angle RLI, and I also know that angle GIL is congruent to angle RIL. If I have an angle bisector, then I end up with dividing into two congruent angles. Step 3 here, I know I got the reflexive property, so I know that IL is just congruent to itself. So IL is congruent to IL by the reflexive property. Step 4 looks like I got an angle, I got another angle, and I got a side here. So it's by angle, side angle, because the side's sandwiched between the two angles. I can say that triangle GIL is congruent to triangle RIL by angle, side angle, and the steps are steps 2 and 3. Of course, you have 2 of them in step 2. All right, that was a nice little short proof there. Let's jump down to proof number 5, because on the front side, I talked a little bit about transitive property. This is actually ends up being one where we have to use a transitive property. So, mark the diagram. First thing, I know that BX is congruent to EX. I know that EY is congruent to YD. And I also know that BX is congruent to DY. So that means that these two are actually congruent to each other. And I knew that these two were originally congruent to each other, so all of them must be congruent to each other. And so when you are doing something like this, and you end up concluding that, for example, XE is going to be congruent to EY, that is all by the transitive property, and I'll show you how to set that up in a proof. I also know from my first givens right here that I have right angles here, and of course those right angles are going to be congruent to each other, so I need a couple steps to do that. And I'm trying to prove that looks like these two triangles are congruent. So I have a side and angle, and it looks like I can do a reflexive side right down the middle there. So that's going to give me my third piece, and the triangles are going to end up being congruent by side, angle, side. notice I'm kind of mapping out my steps prior to actually doing the proofs. It's sort of like when I'm driving from the Northfield campus, from school to the airport, I would not just hop in my car and just randomly start driving. I would map it out, and then that would allow me to get to the place in the most efficient and organized manner, and that's what we're trying to do here when we're setting up these groups. Okay, so let's do this. Step one, let's go ahead and let's start with a reflexive property just for kicks. So CE is congruent to CE. You do not need to start every proof with givens first. Step two, let's go with CE is perpendicular to BD. And I'm going to split up all the givens here because I'm using them for something different. And so now angle CEX and angle CEY are right angles. That's because if I have perpendicular lines, then I end up with right angles. Because those are right angles, I know that they're congruent to each other. A lot of times, students, by the way, will forget this third step. They'll try to jump straight from this to this. I get that you know that's true, but you need to have all the steps. You can't just skip a street in driving from the Northfield campus to O'Hare. So right angles are congruent is my reason. And so now that gives me the angle, right? And so now I need to do this transitive property thing. So let's do that. Let's put all these down here as my givens. Again, please don't do that in an actual or quiz. And then now I can conclude from step 5. I can say that XE is congruent to EY, right? Because if all of that stuff is true, all of this is true, then I can say that this is true. So, and that's by the transitive property. Okay, you can just write transitive. So now I have, it looks like I have a side, I got an angle and a side here. Looks like I'm ready to say that the triangles are congruent. So CXE is congruent to triangle CYE. And it's going to be by side, angle, side from steps 1, 4, and 6. So the tough thing about this, and you know, cry me a river, but this is from a teacher standpoint, is that many of you are going to have this part here in a completely different order, and you're all going to be right as long as you have all this material in there. Proofs, everyone's proofs are going to look a little bit differently. It's okay to do that, but ultimately you need to have all these different steps in here, and you need to be going from the beginning stuff, which is here, and then ending up in the prove statement. All right, so hopefully your first foray into proofs wasn't too bad. We'll go ahead and keep plugging away at proofs, and I promise you'll all get a lot better at doing these. All right, take care.